Now we are looking at chapter number 3, pair of linear equation in two variables of class 10th. So there are various situations which can arise. Before discussing the actual aspect of these equations, let us take a story. Now Akhila went to a fair in her village. Now she wants two things. She wants to enjoy a ride in a giant wheel also, and she wants to play hoopla also. The number of times she played hoopla is half the number of rides she had on the giant wheel. Means if giant wheel is x, number of times she played in hoopla is x by 2. If each ride costs rupees 3, means for giant wheel this is 3, hoopla it will be 4. How do you find out the number of rides she had and how many times she played hoopla provided she spent rupees 20? So this 3 rupees into x plus 4 into x by 2 will be 20. This is the simplest equation we can make. Now we'll see how we can try and make these equation look simpler and solve it. So is it possible to for her to have two rides, one ride, or giant wheel, or no ride? Let us see. We'll solve this query just now. So as I said, if we can denote the ride by x, then of course the hoopla will be x by 2 as I just suggested, because it is half of this. And you know that 3x means 3 times of the wheel to 4 times of this hoopla is equal to 20. Can you find out the solution to this pair? Actually the solution is the solution to the Akhila's problem. So the pair of linear equation in two variable is like this. You have an equation like this. So this is x, this is y. We can make one more equation. We can have various equations. So any equation of this form ax plus by plus c, this is a linear equation. Pair means there has to be two equations. Why? You would ask why we have to have a two equation? Because we have two variables. To solve two variables we have to have two equations. To solve three equations we have to have three equations. To solve or three variables, if there are three variables, we have to have three equations like this. And one more thing, this a cannot be 0 or b cannot be 0. Why? If a and b are 0, then we are only left, if a is 0, we will be left with by plus equal to 0. This is not a linear equation, or it can be a linear equation if you place it 0, but we will not be able to solve it properly. Let us take this equation we just suggested. Place x equal to 1, y equal to 1. If we place x equal to 1 here, y equal to 1, we see that it is equal to 5. Exactly, it is equal to 5. So this is the solution. This is what is the solution, because it is actually satisfying this equation. Right? Now if we put x equal to 1 and x equal to 7, we see that it is actually not solving it, because right hand side is 5. Whether this is equal to 23? No, because 23 and 5 are different. So x equal to 1 and 7 are actually not the solution. So this is not the solution. So what geometrically does it mean? Geometrically it means that if this is a line, 2x plus 3y is equal to 5 is of the form y is equal to mx plus c. If this is a straight line, then 1 lies on this line, while this 1 and 7 does not lie on this line. So any equation ax plus by plus c, if this is the solution, it should lie on this line, otherwise it will not be a solution. Let us take them now formally. These are the pair of linear equation in two variable, one equation, two equation. a1x plus b1y plus c1, a2x plus b2y plus c2. And we have already said that we want this to be intact because we don't want this to be 0. Otherwise it will not be a linear equation, or will not be able to solve for x and y. So these are the pairs of linear equation. These three. Actually these are the pairs. So these are three. Actually there are 6 equations, but the pairs are like this. So there are pairwise 3 equations. So how can we solve it geometrically? We have already seen some sort of things and some discussion in class 9. Two lines can have 3 things. Either these two lines or two equations can intersect, they can be parallel, or these two lines can be similar, means they are equal. Intersection, parallel and coincident. All the discussion in this chapter will actually, take round and go on the periphery of this discussion only. Means it will revolve around these three things. So you should understand it very clearly. So now let us get back to the Akhila's problem. Akhila, y is equal to x by 2. So just take 2 on the left hand side. So 2y is equal to x. So shift this 2y on the right side. This will be x minus 2y equal to 0. Then 3x plus 4y equal to 20. So this already we have seen. These are two equations. Let us solve them. How to solve them? Put some value of x in the first equation, this equation. So you get the y values. So we have placed 0, we get a y value of 0. We place 2, we got the y value of 1. So we are just replacing x so that we can get the value of y. Similarly, for the second equation, we have created it like this, or rearranged like this. Y is equal to 20 minus 3x by 4. So let us place x equal to 0, 20 by 3 and 4. These are just random values, you can take any values. So some value has come. So we have actually got the coordinates. These are the Cartesian coordinates actually. Pair of Cartesian coordinate. And let us make these lines. When we make this line, the whole discussion is about that they are intersecting. And they are intersecting at 4, 2. And this is the solution. This is the solution we are going to get after geometrically representing it. And all the points which we have got, these, they are intersection on the x or y axis. But we are interested in how these two interact, how these two intersect. Let us take one more problem. Romila went to stationery shop and purchased 2 pencils and 3 erasers for ₹9. Let us take pencil as x, eraser as y. So 2x plus 3y is equal to 9. Similarly, for the second friend, Sonali, she also went. She took 4x, 4 pencils, 6y. That is 6 erasers, and it went to 18. We just added. And before going ahead, let me tell you that if I multiply this equation by 2, it will become what? 4x plus 6y is equal to 9 to the 18. These two equations are exactly similar. So they are eventually the same line. So we'll solve it, but you must remember what I'm trying to say here. So similarly, just take y here on everything on the right hand side. So place 0, 4.5. These values are being placed just to get some concrete integral value, so that we can easily place it on the this x and y axis. Again, 0 and 3 we placed on the second axis, we get 3 and 1. Now let us make a line. You see that these two lines are exactly similar. So they can be infinitely many solutions, because for a line, all these points are the solution. Let us take one more case. Two rails are represented by this and this. So these are two rails, and the rails are always parallel, they don't intersect. How they are parallel? Because if you are aware of the slope, that is m, both the equation have the slope similar, but we'll try to solve it the way we are solving it. We'll take some value of x, place it in this, try to find out the y. We placed x equal to 0 here, 4 here, then we try to find out the y. So we have got the coordinate 1, 2, we are going to place it on the xy axis. Again, for the second number line, or you can say second line also, we'll place x0, 6 here, so that we can get y. Now we have got the coordinates of the 2 points for both the lines, we can draw the line. And we see that these two lines are exactly similar. Means not similar, but exactly parallel. Now these are parallel because they are having the same slope. Now, are they going to intersect at all? No. Rails never intersect. So this example has no solution whatsoever. Why? Because they are not going to intersect. You will not get any intersection. So the graphical method of solution of pair of linear equation is very similar to what we have discussed. You just have to take two lines, make them intersect. If they don't intersect, they might be parallel. That means there is no solution. if they don't intersect or they are not parallel, that means they are similar lines, that is infinitely many solutions. These are the aspects which we have discussed just now. So what we are going to call them? Let us summarize. If lines intersect at a single point, we call that these two pair of lines are consistent pair of equations. If lines are parallel, we call, because we are aware that they are not going to provide us any solution, so these are inconsistent pair of equations. And how about coincident? Because those lines are, or these two lines are similar, these are dependent or consistent pair of equations. So these lines intersect, these lines coincide, these lines are parallel. So how to get this in one glimpse? How to get this idea in one glimpse? Is there any way? Yes, we do have. If these are equations, take A1, this is A1, B1, C1, this is A2, B2, C2, like this. Oh, sorry. If this is the equation, A1, B1, C1, A2, B2, C2 will be this. Now, just take this table. A1 by B1, we have taken these three equations, A1 by A2, B1 by B2, C1 by C2. We see here that A1 by A2 is not equal to B1 by B2. This is not equal. So this is intersecting line, we have exactly one solution. These two lines, A1 by A2, B1 by B2, these are equal. And they are also equal to C1 by C2. So these are coincident line. There is only one single line, so they are providing us infinitely many solutions. These two equations, A1 by A2 and B1 by B2, are similar. They are equal, but they are not equal to C1 by C2. In this case arise, we say they are parallel lines, and we are not going to get any solution. So this is what we summarize. A1 by, if these two are lines, A1x plus B1y plus C1, A2x plus B2y plus C2, then A1 by A2 is not equal to B1 by B2, they are intersecting. A1 by A2, B1 by B2 are equal, and C1 by C2 is equal ratio, they are coincident. A1 by A2 and B1 by B1 by B2 is equal, but they are not equal to C1 by C2, they are parallel. Let us take the example. X plus 2y is equal to 6, 2x minus 3y equal to 12. For making any line, we just want 2 points. So we are providing some values of x so that we can get value of y. Similarly here. So we have got the point. Let us make them, and we see that they intersect at 6, 0, and 6, 0 is our solution. So these pair of equations are consistent. How about this equation? These are two equations. To make somewhat easier, this second equation, we can multiply it by 5 by 3. So you can get this 5x minus 8y plus 1. And we see these two lines are exactly similar. When they are similar, that means we have infinitely many solutions because they both are same. How about one more equation of Champa? Champa went to a sale to purchase some pants and skirt, x and y, right? So when her friend asked her how many of each she had bought, she answered, the number of skirt is 2 less than twice the number of pant purchased. So 2x minus 2 means 2 less than of 2x is y, means skirt. Also the number of skirt is 4 less than the 4 times the number of pant purchased. So 4 times the pant purchase less than 4 is the skirt. So these two equations she actually Champa posed in front of her friend. How to solve this? These two are equations, let us make it. And when we see that these two, you by now you know that we are just placing points x so that we can get two points so that we can make the line. So these are two lines, they intersect at 1, 0, and 1, 0 is the solution. So exactly, see, 1, 0 is solution means the number of pants she purchased is 1 and she didn't even buy a skirt. Then algebraic method of solving pair of linear equation. Somewhat difficult is graphical. Why? Because if you want to place these points on a number line or on a say xy axis, it will be very difficult for us. So there are some chances of making mistakes. So we have some different methods also. First is our substitution method in algebraic method. How we are going to substitute? Let us take an example. 7x minus 15y equal to 2, x plus 2y equal to 3. Let us take this equation. X plus 2y equal to 3, place 2y on the right side. So x will be equal to 3 minus 2y. Now place this x here in the first equation. So we are placing the x here, which was 3 minus 2y. Solve it. Y equal to 19 by 29. And as we have seen, that x was 3 minus 2y. We have found the value of y. Just place it here. It will be 49 by 29. So x and y is received by substitution method. So substitution is what? Just make one equation in terms of x in terms of y. Place this x in the second equation or first equation and find out the value of y. And once you got this value, then you can easily get by any equation, means two equations which we actually made earlier, you can get the actual equation. If you did not get it, let us try to solve it in a different terms. See, question 1 of 3.1 exercise. What it says, Aftab and daughter, they are suggesting about their ages. If S is the age of Aftab, T is the age of Aftab's daughter. So what is this? If the age of daughter 7 years ago is 7 times the age of Aftab, and after 3 years the age of the thrice of age of daughter will be the age of the Aftab. So this is what we can make easily. And now let us solve it. So s minus 3t equal to 6. So just make 3t or transfer 3t here. So s you get as 3t plus 6. This 3t plus 6, place it here in place of this s here. So solve it, you get t equal to 14. Now you can place it in this also, this also. So this is seen quite simpler. So let us place it here. So the age of Aftab and daughter is 42 and 12. Again, one more example is about the previous discussion. 2 pencil, 3 eraser, 9. So 2x plus 3y equal to 9. And 4 pencils, 6 eraser equal to 18. So 4x plus 6y equal to 18. Now we have seen already that these two equations are exactly similar. If I multiply this equation by 2, these are similar. But let us solve it by substitution. So we will take this one and place it here, 9 minus 3y, and divide by 2. So x is and 9 minus 3y by 2. Place it here in the second equation. So you get 18 equal to 18. So this statement is true. That means it will have infinite many solution, because they both are similar line. So if this kind of equation comes, that is left hand side equal to right hand side, we say it has infinitely many solutions. One more example we are going to take. These are two equations. Let us solve it by substitution. X, all y comes here. So 4 minus 2y, place 4 minus 2y in place of x here. Solve it, we get minus 4 equal to 0. So this is wrong. It is not similar to what we got 18 equal to 18 in the earlier example. So when this comes, that means it is a false statement. That means it has no solution. It is just like rail. So this is the first part of the pair of linear equation in two variable. We'll be taking second shortly. Till then, thank you so much. Take care of yourself.